This is lesson 3.1 in Algebra 1. We're solving equations using addition and subtraction, beginning on page 132. First thing, we have a few definitions. Equivalent equations is number one. It says equivalent equations are equations with the same solutions as the original equation. Here's an example. X plus 1 equals 3. X plus 1 equals 3. An equivalent equation to that would be x equals 2. Think of equivalent equations as being solutions because you know 2 plus 1 is equal to 3. Or when you transform the equation, you get x equals 2, which is the same as x plus 1 equals 3. Again, equivalent equations have the same solution as the original equation. Inverse operations are operations that undo each other. That's what's important about inverse operations. The inverse of addition is subtraction. The inverse of subtraction is addition. Same thing's true we're going to look at tomorrow or on Wednesday. The inverse of multiplication is division, and the inverse of division is multiplication. They cancel each other out. A solution step is a step of a problem. Anytime you change a problem, for example, x plus 1 equals 3 from earlier, the same thing. The solution step would be to do the inverse operation of plus 1, which would be to subtract 1 on the left and the same thing on the right. That would give you x equals 2. This is a solution step right here. To subtract 1 is your solution step to give you x equals 2. So each time you change the equation, there's a reason why you change it. You don't just do it because you feel like it. When it becomes something different, each step is called a solution step. A linear equation has the word line in it. It starts with it. Think of it as a straight line. Okay. What makes it a straight line is when y is equal to x plus 1. What makes it a straight line is that this x is being raised to the first power. Anytime you have x to the first power, it is an equation, or it is a linear equation more specifically. What makes these two linear equations is that there's nothing raised to the second power. You don't see anything but the first powers, even though they're not shown. Anytime it's not shown, remember it's considered 1. They're all raised to the first power. Neither of them are in the denominator inside of square roots or inside absolute value symbols. Notice on the ones where it says not a linear equation, we have an absolute value symbol. We've been working with those. That's not going to be a linear equation. That's going to be an equation that looks like this, or it's going to look like this. It's going to be a straight V. The one above it, x squared plus 5 equals 9, you can see clearly that that one says x squared. That's called a parabola equation, and it's going to look like this. Anytime you see x squared, it's going to look like a big U when you grab it. Not a straight line. Yes, this makes a straight line here, and this makes a straight line here, but the two of them together, it's not a straight line. It makes a V. Okay. Here are transformations that produce equivalent equations. The first one is adding the same number to each side. Think about when you're doing inverse operations. Think about when you are doing inverse operations. As you're changing the balance of things. And if you look in the textbook, you'll see that there's pictures of scales and stuff in there. So you have something that looks like this. If you have x plus 1 over here and you have 3 over here, the scale is balanced. If you do an inverse operation and you subtract this plus 1 right here, you subtract it, now all of a sudden this is going to be lighter on this side. The left side is going to be lighter. It's going to cause it to go up. And now this one's going to be heavier. It's going to cause it to go down. So in order to fix it, you have to make sure to balance the equation. That's where the term balance in equations comes from. If you subtract 1 on the left side, you have to subtract 1 on the right side to keep it, to make it back balanced to where it doesn't go up and down. It stays like it's the same pull on each side. So here are your transformations. It says x minus 3 is equal to 5. In order to undo minus 3, you simply add 3. And if you add 3 to the left side, you have to add 3 to the right side to keep it balanced. And 5 plus 3 gives you the number 8. Another transformation is subtraction. Subtracting the same number from each side. This one says x plus 6. Undo plus 6 by subtracting 6. If you subtract it on the left side, subtract it on the right side. 10 minus 6 is the number 4. This plus 6 minus 6 will cancel out, as will this minus 3 plus 3, and leaves you with just x. Okay, simplifying one or both sides, x equals 8 minus 3. Now you're simply doing, the x is already isolated, it's already by itself. So you're simply combining 8 and negative 3, or 8 minus 3. 8 minus 3 gives you 5. You don't have to do inverse operations when you don't go across the equal sign. Okay, that's a very common mistake students will make. They'll think, okay, well, I have minus 3, I have to add 3 right here, and then add 3. No. If you are simplifying one side of the equal sign, think of it as a left side and a right side. If you are not going across the equal sign with something, you're just doing whatever operation it says. It says 8 minus 3, so you subtract 3 from it to get x is 5. And then interchanging the sides, 7 is equal to x is the same thing if you just want to put the x first and say x is equal to 7. Changing both sides. So here are 4 transformations: adding the same number to both sides, subtracting the same number, simplifying one or both sides, and then interchanging the sides. Okay. Then here's example number 1. It says solve x minus 9 is equal to negative 20. Your goal, you have the equation x minus 9 equals negative 20. Your goal at the end of this problem is to make it say x equals all by itself. Notice we don't have x equals. We have x minus 9 equals. So what you want to do is some people draw a line, they draw a river. They learned it as crossing the river. You want to get anything that's on the left side that's not x to go over to the right side to where x can be all by itself. It says minus 9, so you undo minus 9. The inverse operation of minus is to add 9. If you add 9 to the left, add 9 to the right. Now you have negative 20 minus 9. Think of that number line where you don't make a mistake. If you start off at negative 20, you're adding 9. Adding 9 means to go this way 9 times. And you're going to get negative 11 for that one. This part right here cancels out. Negative 9 plus 9, negative 20 plus 9 is going to be negative 11. It says remember that you need to add 9 to each side to balance it. And you can see the way I have it written here is the vertical method. This is called the horizontal method. People do it both ways. Sometimes I'll show you both ways just the way you can have an option. If you look off to the left, it says you can check your solution by substituting whatever you got for x, your solution, in the original equation and checking to see that it comes out to be true. So the solution is negative 11. So when you plug it in, x minus 9 equals negative 20. In place of x, we're going to plug in negative 11. Minus 9 equals negative 20. And all you're doing at this step is checking its truth value. Negative 11 minus 9, you're not moving across the equal sign, so you just combine those two. Starting at negative 11, minus 9 means to go this way 9 times. You get negative 20 equals negative 20. That's a true statement. Okay, take about 15 seconds to do this one. Okay, we went a little bit longer than 15 seconds. The goal is to get x by itself. Think of getting that by itself. We don't have x by itself. We got x minus 9. So we want to move minus 9 or negative 9 over. The inverse of minus 9 is to add 9. If you add it to the left, add 9 to the right. What that does is that'll cancel out minus 9 on the left and get us x all by itself. Okay, now we have negative 17 plus 9. When we combine those, think of a number line. If you're starting at negative 17, plus 9 means to go this way 9 times. And if you go that way 9 times, you're going to get negative 8 for that one. X is negative 8. You can plug it back in. Negative 8 minus 9 does, in fact, give you negative 17. So it is a true statement. Here's example number 2. Now this one's simplifying first. Just like in our bell word today, we have minus a negative. Minus a negative is the same thing as negative 1 times negative 8. We know a negative times a negative is a positive. So when we simplify that, now we have n plus 8 is equal to negative 2. The fact that this says n and not x, don't let that confuse you, everybody. You treat variables the same way. So now you have n plus 8, because minus a negative means to add. And then you got to undo plus 8 by subtracting 8 on both sides. Again, if you did it the vertical method, which most people prefer, n plus 8 equals negative 2. Subtract 8 on both sides since you want to move that. You want to get n equals all by itself. We want to move plus 8 over. So you subtract 8. Negative 2 minus 8 is going to be negative 10. Think of that number line. You get negative 10. So when you plug that negative 10 in, negative 10 minus a negative 8, that's what the original equation said, equals negative 2. Remember, minus a negative means plus a positive. So negative 10 plus 8 equals negative 2, and that is a true statement. Think of where you start on a number line. You start at negative 10. When you add 8, you go to the right 2 times. You don't quite get to 0. You get at negative 2. Okay, take about 30 seconds to do this one. Okay, we have negative 11 is equal to n minus a negative 2. Before you go across the equal sign from left to right or from right to left, you need to simplify each side of the equal sign. This says n minus a negative 2. Remember, anytime you have minus a negative, it's the same thing as a negative times a negative. So what that gives you is n plus 2. Minus a negative means plus a positive. So now we have negative 11 is equal to n plus 2. We want at the end of this problem for it to say n equals all by itself. We don't quite have that. So we have to undo plus 2 right here. We want to undo it. We want to bring it over. In order to undo plus 2 or positive 2, you subtract 2. That's the inverse operation. Remember, addition undoes subtraction. Subtraction undoes addition. Don't try to think this is division. Okay. If you subtract 2 on the right-hand side, you have to do the same or your equation is going to become unbalanced. It'll cancel right here and leave you with n. That's what we were trying to get. Negative 11 minus 2 starts off at negative 11. It says minus 2. You know your negative numbers are this way, so negative 12, negative 13 is where you're going to wind up. And remember, the transformation says you can move these and make it say n equals negative 13. Most of the time, it's not necessary to write it. You could simply read it from the variable. Instead of saying negative 13 equals n, just simply read it as n equals negative 13. Okay, then we have 6 checkpoint problems, very simple ones. The first one, x minus 7 equals negative 15. We want to get x equals by itself. That's the goal. We don't have that. We have x and we have minus 7 with x. Undo minus 7. We want to cancel out minus 7. So we add 7. If you add 7 to the left, you have to balance it by adding 7 to the right. Now you have negative 15 plus 7. Think of your number line. Always think of your number line. You start off at negative 15. Plus 7 goes this way 7 times. 1, 2, 3, 4, 5, 6, 7. Right here is going to be negative 8. X is equal to negative 8. You have to simplify for number 2 the left side of the equation before you can undo anything. Simplify the left side. It says minus a negative. Remember, all that means is plus a positive. So when you simplify that, it gives you n plus 6 is equal to 4. Again, you don't have the variable by itself. You want to isolate that variable. We want it to say n equals all by itself. So in order to cancel out plus 6, the inverse of plus is subtract 6. If you subtract 6 on the left, you have to subtract 6 on the right. It'll cancel it out on the left and give you n. 4 minus 6, again, think of that number line. If you're going, starting at 4, minus 6 goes this way. You're going 4 times 5, 6 times negative 2. Then negative 7 equals 10 plus y. Okay, now this one's written backwards. This one's kind of confusing to people. Remember, the order you add and subtract and stuff, it doesn't matter. You can have the commutative property says you can change the order. However, we're looking at this problem. We're trying to get y equals all by itself on the right-hand side of the problem or on the left-hand side. It's already on the right, so there's no reason to move y over to the left. Okay, it says 10 plus y. That means that those two numbers, 10 and y, are adding and subtracting with each other. But this doesn't tell you how to undo 10. 10 is a positive number. It's positive. That's what tells you how to undo it. If that would have been negative, you would have to undo it by subtracting. But it says plus 10 since it's positive. Undo that by subtracting 10. If you subtract 10 on the right, you need to subtract 10 on the left. Negative 7 minus 10. Again, think of that number line. You add negative 7 minus 10 is to go 10 more times that direction. So you get y is equal to, if you do it like that, you get y is equal to negative 17. And notice how I read it. Even though it says negative 17 equals y, I read it from the variable. Y equals negative 17. Number 4 says 5 minus a negative z is equal to 21. Again, anytime you have minus a negative, it means plus positive. 5 plus z equals 21. Okay. We don't have z equals by itself. That's the goal, to get z equals by itself. We have 5 plus z. So that means they're adding and subtracting. But this plus doesn't tell you to undo it. It's just a coincidence that they're adding and subtracting. The fact that that one's positive tells you how to undo it. Undo plus 5 by subtracting 5. If you subtract 5 on the left side of the equation, subtract 5 on the right side of the equation. 21 minus 5, this part will cancel and leave you with z. That's what you was trying to get. 21 minus 5 is the number 16. Okay, you have to simplify for number 5. It says m minus the absolute value of negative 3. Remember, you have to do absolute values as if it's a grouping symbol. You got to do that first. That means how far away from 0 is negative 3. We know that it's 3 away from 0. So bring everything else down. M minus and then equals 14. Now it's a simple equation. Get m by itself on the left side of the equal sign. In order to get it by itself, you have to undo minus 3. Undo minus 3, you know its inverse operation is add 3. If you add it to the left, add 3 to the right. It'll cancel out and give you m. That's what you was trying to get. 14 plus 3 is 17. And then the last one from the checkpoint says negative 8 is equal to negative b plus negative 2. Okay, now there's two different ways to do this, and on Wednesday when we learn multiplication and division, we'll do it slightly different. But for right now, we want to bring negative b over to the opposite side. Okay, so how do you undo minus b? You know you undo minus b by adding b. If you add b to the right, you have to add b to the left. So now you have positive b, and then bring everything else down. Minus 8 is equal to, it says plus a negative 2. That means minus or negative 2. Now we have a simple equation. This was a multi-step, but it's a simple equation at this point. You still have a left side and a right side. Your goal is still to make it say b equals all by itself. Undo minus 8 by adding 8. If you add 8 to the left, add 8 to the right side. It'll cancel the left side and leave you with b. Negative 2 plus 8, again, you start at negative 2. Plus 8 means to go to this. 2 to get to 0, and then 6 more to move it 8 times. So it's at positive 6. So you should have b is equal to positive 6.